All right, so we're going to talk today about finding length using the distance formula. Now, the distance formula isn't the only thing that we can use to solve these questions, but it's one of the things that we'll use. Often the length of a segment can be measured using a ruler, right? When we're dealing with things that are in the real world, we'll break out a ruler, test and see how long something is. That's not typically a problem. At other times, it may be necessary to find length by looking at a number line or coordinate plane because we're working with something that's not necessarily tangible. Okay, we're talking about, things that are mathematical in nature. To find the distance between 2 points on a number line, we take the absolute value of the difference between those points, between their coordinate points. So distance here is the absolute value of A2 minus A1. Okay, the distance doesn't change. Either one can be, we've got a point number 1 here. We've got 1 and 4, right? You can tell as you count here, 1, 2, 3, what the distance is. But if I work this out, the absolute value of 4 minus 1, well, that's 3. The absolute value of 1 minus negative, 1 minus 4, okay, is still 3. Because 1 minus 4 is negative 3, and the absolute value of negative 3 is 3. Distance is always positive. That's why we use absolute value signs. Okay? You follow me so far? All right. So you can count, but the reason that I want you guys to know this formula that you see here is because what if I was looking and talking about things like what is the distance between 586 and negative 1,293 on a number line, right? You're dealing with numbers. Do you really want to sit there and count, right? And besides that, your number line might not be each tick mark equals 1, right? Each tick mark on a certain number line might be a fourth or an eighth or a 16th, right? Or by half, right? So if you go counting tick marks, assuming that those tick marks equal 1, right, you're going to wind up with much more distance than is actually there. You leave yourself room to make a lot more mistakes. Whereas if we use our formula here for solving for distance on a number line, we're far less apt to make a mistake. So we see that the distance between A1 and A2 does not matter which one is A1, doesn't matter which one is A2. You're still getting 3 for an answer because it's absolute value. Okay? All right. On a coordinate plane, the distance between 2 points can be found using the distance formula. Distance formula is as shown. If I have 2 coordinates, x1 and y1, x2 and y2, just 2 coordinates that show up in an xy coordinate form, okay, it's given by this formula. This is a formula that you need to know. That guy right there. That needs to be in your notes. You need to write it down. You need to know it because you're going to need to be able to use it. Okay? Now, there is another way of solving questions that gets you the same answer, but today we're working with the distance formula. Now, the important thing to understand is that it does not matter which ordered pair. If you're looking for the distance between 2 coordinates, it doesn't matter which set of coordinates is x1 and y1 versus which set of coordinates is x2 and y2. It's the same concept that we talked about earlier in the school year whenever I said, I could ask the question, how far is it from Milan to Kirksville? And I would get the same answer if I asked you the question of how far is it from Kirksville to Milan. It doesn't matter which one comes first, does it? Is the distance still the same? Yeah, the distance is still the same. So it doesn't matter which coordinate between 2 coordinates is x1 and y1 or x2 and y2, but what does matter is that x1 and y1 come from the same ordered pair. Okay? I don't want a setup where I have x1 and y2, x2 and y1. That will mess it up. Okay? They have to come from the same ordered pair. Any problems up to this point? How many of us are familiar at least somewhat with the distance formula? Okay, I see most, if not all, hands go up. Okay, that's fine. If you're not, we're going to be working with it anyway. So when 2 points share the same x value or y value, the distance formula can be simplified down, right? If they share the same x coordinate, then there's zero distance between those two x coordinates, right? Which means I can shorten that thing up. Okay, now I'm only looking for the distances between their y's. Okay, or vice versa. If my y coordinates are the same, I'm looking at basically a horizontal line. I'm only looking for the distances between their x's. All right, so let's look at some questions. Let's see what we need to pull. Let's see, lesson 9. Okay. I'm going to come off over here where we got some space to work with. All right, so we want to find the distances between -5, -1, and 1, -2. All right, I would just go ahead and list them: x1, y1, x2, y2. Okay, call your first ones first. Okay. Okay, what do I want to have in here? Go ahead, Jordan. 1 minus -5. Okay, what goes up here above the anything there? Squared. Okay, then what goes in between? What goes here? Is it minus or plus? Plus. Okay. All right, so he got the x's. Who's got the y's? If I'm doing 1 minus -5, what do I have to do next? Okay, Chandler?
-2 minus -1.
-2 minus -1. Okay, good. What happens with these double negatives that we're looking at here? What do they become? They become positive. Okay, so as I'm looking in here, I have 1 plus 5. What's 1 plus 5? 6. So you're looking at that. I'm just going to keep this. We could do some of these steps all at the same time, but we're just going to see how they break down. -2 plus 1, -1 squared. Okay, let's come down to our next step. What's 6 squared? 36. What's -1 squared? So I wind up with square root of 37, and because 37 is prime, we can't simplify that. It's just simply square root of 37, right? Okay. Do we feel comfortable enough with the distance formula that we can do some of those on our own? Okay. Chandler, how about you? You're about the only guy I didn't see. You're familiar with it? Okay. All right. All right, let's come down here real quick to number 3, find the length of CD. I know that you could count, right? But do you notice anything about the tick marks? They're in between, right? So we can't just count, can we? All right, so let's set up our absolute value. Again, it doesn't matter if we're looking for the distance from C to D or the distance from D to C. But what I do is I subtract the two numbers, right? So let's go from C. What's the location of C? -8. So I'm going to do -8 minus what? -1.5, right? -1.5. Okay? We know we're going to add there. So what's -8 plus 1.5? Well, we have opposite signs. Okay, so I don't know if it was this class or another class where we talked about adding or subtracting. I think it was adding terms with different signs. Did we talk about that in this class? No. This would have been Algebra 1. So without getting out a calculator to do this, what we do whenever we're adding numbers of different signs is we take the number with the greater absolute value. Which number, -8 or 1.5, has the greater absolute value? -8. So we're going to write 8, and we're going to subtract 1.5. Okay? And because -8 is the larger absolute value, I'm going to put a negative with my answer. So what is 8 minus 1.5? Okay, well, what's 8 minus 1? 7. Now take off another half. -6.5, right? -6.5, which means, what is the actual distance? 6.5. Okay, does that help a little bit? Okay, so we should get CD equals 6.5. And when you're seeing length and you see negative answers pop up, you can automatically, if it helps you out, go ahead and get rid of those because length will never be negative. Okay? All right, let's see if there's some other questions in here. Number 4, find CD and EF, then determine if CD equals EF. This is where I'm going to show you another way, okay, besides the distance formula. Now, should you know the distance formula? Yes, but I want to show you something else, okay? This is the length of the line that I'm looking for, correct? Okay. What I'm going to do, though, is I'm going to make a right triangle here. And I'm going to come over here and I'm going to make a right triangle here. The lines that I'm looking for are these. Okay? Now I have 2 right triangles, okay, that I can easily find lengths of. This is 2 and this is 3. This is 2 and this is 3. How might I find the lengths of my red lines using these triangles that I've made? Pythagorean theorem. Notice I should know right off the bat, though, because I have a 2 and a 3 here, and I have a 2 and a 3 over on my EF, okay, that should EF and CD be the same length? What? Yeah, because I'm working with the same numbers. So if I come over here, I have 2 squared plus 3 squared equals C squared. 2 squared is 4 plus 9 equals C squared. That's 13 equals C squared. Square root of 13 equals C, and it would have to be the same thing on both. Therefore, they are congruent. Now, if you're going to use the distance formula, it's going to take a little bit more because what you're going to end up having to do, the distance formula requires that you know the coordinates. So for F, you have to know that that coordinate is -4 and -2. Okay, for E, you have to know that that coordinate is -2, 1. Right? And now I have to plug those coordinates into the distance formula and go on down from there. The Pythagorean theorem doesn't require me to know the coordinate locations, just the distances, right, of those legs of that right triangle. So do you see how in certain instances, not in all instances, but in certain instances, the Pythagorean theorem will get you the same answer, right, as we'll see. Okay? Okay, if we take this, right, I'm taking my -2 minus -4 squared plus 1 minus -2 squared. Come down through here. Plus, 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 plus. -2 plus 4 is 2. 2 squared is 4, right? 1 plus 2 is 3. 3 squared is 9. Do I still get square root of 13? Yeah. But now I'm going to have to find the coordinates for C and D and do the same thing again. So we still get the same answer, but in certain situations, we can save ourselves a little bit of time by being able to use the Pythagorean theorem. Does that make sense? I'm not trying to steer you off track. And if you want to use the distance formula every time, use the distance formula every time. Okay? Whenever they're just giving me coordinates, though, I want to use the distance formula. If they give me lines out here like this, sometimes the Pythagorean theorem is easier. Okay? Number 5, the distance formula is easier. Okay? Now I can show you how to use the Pythagorean theorem, but it's essentially the same thing as using the distance formula. Okay? All right. I kind of feel like at this point you guys are in good enough shape that I can hit stop here. I'll let you guys work. I'll walk around the room. If you have questions, you get stuck. Okay? I want you to be able to go into the weekend not completely stressed out. So, all right?